Hello friends, I am Samir and I welcome you all to your own YouTube channel Aryabhatta. Friends, today we are going to discuss about finding the inverse of a square matrix by elementary transformations. So, elementary transformation means change of form, elementary means element wise. So, if we are calculating something or we are changing the form or the look or the numbers or the elements present in the matrix by some operations, then that is called elementary operations or elementary transformations. So, through some transformation of elements which is called elementary transformations, we are going to find out the inverse of a square matrix. So, friends, let us discuss what elementary transformations means. What is the meaning of elementary transformation here? A matrix can be transformed into another matrix or another form by changing its rows or columns through some elementary operations or transformations which are given below. So, you can see three operations are given. So, these three operations are considered as elementary transformation or elementary operations. So, only these three operations. There are many other properties of a matrix, but only these three operations are taken as elementary operations or transformations. So, what are they? Those three, friends? Let us see. First operation is or transformation is interchanging any two rows or columns. We can change any two rows or any two columns. Changing or interchanging or changing the places of two rows among themselves or two columns among themselves is called one of the elementary operation or transformations. That we can denote like this. Say R1 row 1 I am changing with row 2. So, I can write row 1 double arrow row 2, same for column. Now, second operation is second elementary transformation is multiplication of the element of any row or column by a non-zero quantity. We can replace one row with the scalar multiple of the elements of that row, or same thing for a column. We can change the elements of a particular column by multiplying a scalar with that column. Say I want to change the first row by the sixth time of that row. So, I will multiply 6 with all the elements of that row 1 and I will change it. So, I can write R 1 arrow 6 R 1. That means, I am changing the row 1 by the 6 times of the elements of row 1. Okay, friends. This is also called one of the elementary transformations. Now, the third elementary transformation is the addition of a constant multiple of the elements of any row or column to the corresponding elements of any other row or column. This is a very important one. We discussed this before also. Say I want to change the row 1 by adding a constant with another row with row 1. That means, say I want to change row 1 with multiplying 6 with row 2. Then I can write row 1 arrow row 1 plus 6 into row 2. That means, I am multiplying 6 with all the elements of row 2 and that I am adding with the corresponding elements of row 1, and the whole I am replacing in place of row 1. Same for column also. So, changing the any row or column by scalar multiple, non-zero scalar multiple, and addition of a row with a scalar multiple of elements of another row, and changing the place of that or replacing the place of that. These three operations are called elementary operations. Now, one question may come in your mind that if you are applying these three elementary operations, then that matrix is going to change, the elements will change. If elements will change, then matrix will automatically change also. But do the original matrix will remain the same matrix after doing all these operations? No. It is already told to you that a matrix will be transformed into another matrix. Matrix will change to another matrix, the matrix will change, it will become a new matrix. If the element will change, then the matrix will also automatically it will change. Then what is the relation between the first matrix, the original matrix, and the change matrix? They are equivalent matrix. The original matrix and the new matrix or the changed matrix obtained by any of these elementary operation, they are called equivalent matrices. So, two matrices A and B are said to be equivalent if one can be obtained from the other by a sequence of elementary transformations. So, if we are applying any of the elementary transformation or operation or some of the elementary transformation or operation on a matrix, then that matrix will change to another form, that matrix will change because its element will change. So, they may not be equal to each other, they will not be equal to each other, rather they are called equivalent matrices. And this double wiggle symbol, double wave like symbol, this is called wiggle. This double wiggle symbol is used for equivalence. If A and B two equivalent matrices, then they are symbolized like this, A double wiggle B. Okay friends. So, we came to know that what are elementary transformations, only three transformations are allowed, and by doing elementary operation on a matrix, that matrix will definitely change to another form, it will be a different matrix, and that is called equivalent matrix. Now, let us use this concept to find the inverse of a or inverse of matrices. So, first of all friends, let us apply this concept and find out the inverse of a matrix. For that, let us take a matrix A. Let A be an invertible square matrix of order n. Say A be a square matrix which is invertible, means its inverse do exist, and say I be the unit matrix of the same order n. So, here I am taking two matrices A and I. A is our matrix of which I have to find the inverse, which is a square matrix and also invertible. That means, there is no issue of its inverse, we can get it, which is of order n, and I is the same n order unit matrix. So, friends, I can use two type of operations here, elementary operations here. One is called elementary row operations and the second is called elementary column operations. That means, I can use the elementary operations row wise or I can use the elementary operations column wise. Both I can apply and I can get the inverse. Now, one question may come to your mind that can we apply both together in a single matrix in different steps to calculate its inverse? No, it will be good for you or it will required for you or it is instructed to you to use either the row operation or the column operations. If you are applying row operations, if you have chosen to use row operations, then you keep to row operations only because it has a procedure, and if you are applying column operation, you keep to column operations because it has another procedures. So, in row operations we will calculate through rows only, in column operations we will calculate or transform, we will apply the laws through columns only. So, friends, let us discuss the elementary row operations. Here we use the equation A is equals to I into A. If I am multiplying a matrix, on the right side of it an identity matrix of same order, then it will not change. We know this formula. So, we can write A is equals to the product of I into A, I into A. Then will transform this matrices involved in such a manner that then we will try to transform these matrices in a particular manner. What is the manner? Let us discuss. In the first step, the post factor of A in the right hand side is left unchanged. Pre means before, post means after. You can see on the right hand side there are two matrices I and A. I is the pre factor and A is the post factor. Here this post factor A will not be touched, it will be unchanged, it will be kept or left unchanged. So, A, the letter A, the matrix A, the name of the matrix A will write only and will not change it at all. Second step is the matrix A in the left hand side, the matrix A in the left hand side gets transformed into the unit matrix I, will change this A to its equivalent identity matrix I, will change this A to I through row operations which are to be reflected onto the prefactor I. That means, we will try to change this left hand side A matrix to its same order identity matrix, and for that whatever the row operations or transformation will use the same operations on the right hand side identity matrix, and this post factor A, it will remain unchanged. So, only A and I will change and this A will not change, and ultimately after applying different row transformations, this left hand side A matrix will change to the identity matrix, because we are knowingly calculating them in such a way that we will get identity matrix. It will be our aim to get I here on the left hand side. So, after that something will happen and we will get something in this form, I is equals to B into A. This A is not going to change, I told you. So, this identity matrix here, which the prefactor I, it will change to, by using same operations, row operations, it will change to another matrix. I told you the matrix will change after applying elementary operations. So, whatever the operation we are applying on the left hand side A, we will apply the same on the right hand side I. So, A will change to I and I will change to another matrix, another equivalent matrix B. The result will be I is equals to B into A. But we know that if you are multiplying two matrices and we are getting identity as the result, then those two matrices are inverse of each other. That means, A inverse is B and B inverse is A. That means, our aim is to find A inverse. So, A inverse is nothing but the B matrix obtained here. So, A inverse is equals to B. Okay. So, very simple process. We will start with A is equals to product of I A, left hand side A and right hand side I will apply some elementary row operations, and right hand side A, the post factor A will not change, it will be remain the same. Now, whichever the row operations we will use on the left hand side A matrix, keeping in mind that we will convert it, or we are going to convert it to the same order identity matrix, the same operation will be applied on the right hand side identity matrix. In that process, after some step, we will come to a stage like this, where left hand side matrix totally it will be changed to or transformed into the identity matrix, and right hand side the matrix A is unchanged as we are keeping it, and in place of I we will get a new matrix, say it is B, then this matrix B is nothing but the inverse of the matrix A. Whatever we will get on the right hand side in place of I, that matrix, that equivalent matrix with I, is nothing but the inverse of the matrix A. This is the whole procedure, friends. I hope you understand this. Let us apply this on a given matrix. Let us work out an example. Apply elementary row operations to find the inverse of this matrix. It is a 3 by 3 order square matrix. Let us find out the inverse of it. First of all, friends, let us name it. Let A be the name of this matrix. So, it is given to us that we will apply row operations. So, for row operations we have to write A is equals to I into A. So, we have written A is equals to I into A. This right hand side A, matrix A, we are not going to change at all. It will, so we will keep write the name only, because there is no requirement of changing it. So, we will keep the name only here. We will not write the total matrix, because it will take the, it will waste a lot of time. So, we will keep the name A as A only. In place of the left hand side A, we will write the full matrix, and in place of the I will write the total identity matrix, because these two matrices I am going to work on element wise, and I am going to use elementary operations, row operations on this. So, my aim is to change the left hand side A matrix to identity matrix, same order. I know that identity matrix is something looking like this. This is the identity matrix of same order. The diagonal elements are all 1 and the non-diagonal elements are all 0. So, it will be my aim to make this left diagonal elements all 1 and the other elements, other non-diagonal elements 0 by applying elementary row operations. So, I have decided to interchange the row 1 with row 3. So, if you interchange row 1 with row 3, what will happen? Here 1 will come, here 0 will come, here 2 will come. Row 1 and row 3 will interchange, and the same thing I will do on the right hand side identity matrix. My aim is to bring this 0 to here. Okay, friends. So, let us interchange row 1 with row 3. After changing row 1 with row 3, we are going to get this one, this relationship. Now, if I am applying the row operations, then I will get the identity matrix on the left hand side column wise. First of all, the first column will become identity, then the second column will become identity, then the third column will become identity. And if I am using column operations, then rows will become identity. Okay. So, as I am using row operations here, my aim will be to convert the columns to respective identity matrix. So, for that I will change the row 2 with multiplying 2 with row 1 and subtracting with row 2. So, R 2 minus 2 times of row 1 I will replace with row 2. So, from row 2, if I will multiply 2 with row 1 I will subtract, then what will happen? It will become 0. 2 into 1 is 2, 2 minus 2 is 0. I told you, if I am using row operations, that means I will get the identity matrix gradually column wise. That means first this column, first column will become 1 0 0. My aim is to do that. So, multiply 2 with row 1 and subtract from row 2, and this element 2 in the column 1 in the second place will become 0, and the same thing you have to do on the right side identity matrix also. Here also you multiply 2 with row 1 and subtract from row 2. Okay. So, here you remember that I am not changing row 1, I am just subtracting 2 times of row 1 with from row 2. So, row 2 is changing, not row 1. Okay, friends. So, apply that operations and you are getting something like this. Now, to make this identity, this first column identity, this third element of the column, that which is 1, it should be 0. For that I have to use the row 1 again. If I will subtract row 1 from row 3, then 1 minus 1 will become 0. So, let us change row 3 with row 3 minus row 1. These two operations you can do at one place also here, if they are not hampering each other. You can do these two steps in one place also, two calculation in one step. It is okay, I have done this, I am doing whatever I am doing on the left hand side, the same I am doing with the elements of the right hand side identity matrix. So, let us do it, and by that I am getting the result. and gradually I am calculating and converting the elements through these steps, and I am getting the inverse of the matrix. Okay friends, here this will be 0, and after converting the first column to 1 0 0, looking like the first column of the identity matrix, I will focus on the second one, second column. Second column element should be 0 1 0, it is already 0, it is already 1. Now I have to make this 2 change to 0. For that, definitely I will use the row 2, and I will multiply 2 times with row 2. So 2 into 1 will become 2, and 2 minus 2 will become 0. So that is why row 3 minus 2 times of row 2. Same thing operation, same operation you do on both sides, and it will change to, you see the second column now becomes the column of the identity matrix. Now in that way, now our aim will be to convert the last column, third column. It should be 0 0 1. Already 0 and 1 is present, only we have to convert this 2 to 0. For that, definitely we are going to take the help of row 3. We are multiplying 2 with row 3, and we are subtracting from row 1. So 2 into 1 is 2, and 2 minus 2 is 0. So this approach I am applying here. The same thing I will do with the rows of, or the elements of the rows of, on the right hand side, and after this step I am getting a full identity matrix on the left hand side, and on right hand side I am getting a new equivalent matrix of that previous identity matrix with A being unchanged. So if product of this matrix with A is resulting in I, identity matrix I, that means these two matrices are inverse of each other. That means this new matrix on the right hand side is the inverse of the matrix A. So that is why A inverse is the right hand side matrix obtained. So this is the elementary row operations, friends, which is very easy. Remember one thing, if you are applying elementary row operations, that means we are adding or interchanging rows with rows, or then our result will come gradually column wise. Okay friends, I think you are a little bit clear about these operations. The same process is adopted for elementary column operations with little change. For that, let us discuss elementary column operations. Here we take the equations A is equals to AI. Remember, in row operations I have written A is equals to IA. Here I am writing A is equals to AI. So only change of place. The same process will be adopted. We will keep the right hand side A matrix on change, and will work on the elements of the left hand side A matrix and the right hand side post factor I matrix. This left side A matrix and right side I matrix, as before, will apply elementary column operations. And if I apply elementary column operations, that means I will calculate columns with columns, then the result will come row wise. And after applying the same operations, I will get something like this. I will get something like this form, as this right side A I am not changing at all, and left side A I am applying column operations to change it to same order identity matrix. So my result will be I is equals to A into B. This identity matrix, after getting impacted by those elementary column operations, will change to another equivalent matrix B, and if product of two matrices is identity matrix, that means they are inverse of each other. That means B is the inverse of A and A is the inverse of B. So B is equals to A inverse obtained in this process. Friends, let us discuss this one through one example. Here I have taken a second order square matrix, and let us apply elementary column operation on this. First of all, let us name this matrix A as A matrix. So now I can write A is equals to A into I. I told you I am not going to change the right hand side A matrix. So I will keep the write the name only, because it is unnecessary to write the whole matrix without changing. So, I will write the name A only. So, left hand side matrix I will write, right hand side identity matrix I will write in full elements, element wise I will write. Then my aim will be to calculate in the same procedure that I had adopted before, as I am using column operations. So, my aim will be to get the results row wise. So, left hand side my aim will be to convert this left hand side matrix A to its identity matrix, same order identity matrix, and you know identity matrix elements, column elements or diagonal elements sorry are all 1, non diagonal elements are 0. So, my aim will be the same doing column operations and convert the left hand side matrix A to identity matrix, and the result the same operation I will use on the right hand side matrix, and in that way the whatever the equivalent matrix I will get on the right hand side with A multiplied with A, that is the inverse of the matrix A. So, in this way I obtain this. So, friends, I hope you understand both the process, but remember again, if you are applying column operations the result will come row wise, and if you are applying row operations the result will come column wise. So, I hope you are relatively clear about these elementary operations on row and columns to find the inverse of a matrix. So, friends, thank you very much for watching this.